All right, example 2. This one doesn't have any pure in it. Okay, so again, if it's pure, they don't use the word pure, but if they just say how much water, how much salt, how much oil, how much alcohol, whatever, they're talking about pure stuff, okay? If it has percentages and everything, that's fine. Okay, glycol is, I think it's kind of like an antifreeze, if you're interested. But Virginia Campbell had 100 kilograms of a 20% glycol solution. How much 40% glycol should they add to get a 35% glycol? So how much should they add? So they're adding, so notice we're adding. So again, the word evaporate implies subtraction. Everything else we typically add things together. They might say extract it. If they say extract, that's also subtraction. But beyond that, usually we're adding things together here. So we're mixing the 20% glycol and the 40% glycol to get a 35% glycol. Okay? In general, when you're adding things together, something too weak and something too strong can create something in between. Okay, so anytime you got a plus here, expect on the plus side, too weak, too strong equals something in between. That's possible. I can't mix a 20 and 35 to make a 40. That's not possible. All right? So the percentages, we're trying to work in between the percentages, too weak and too strong. Now, what makes it different than before? Because again, before they told us this number here. We knew how much we wanted to end up with. We didn't know either of these numbers here. But this time they had 100 kilograms of a 20% glycol solution. We know this number. How much 40 should they add? So we're trying to add an unknown amount of 40% glycol to end up with the correct percentage glycol. We don't care how much we end up with though. We have a bunch of this 40% glycol solution, so we can keep on pouring it in until we get the right percentage of 35%. And then we're going to have this container 35%. We can pour out as much as we need it once we create the right percentage. Okay, so get the percentages set up properly, and then again, establish where things belong. And this should be fact down here, the bottom. So this plus this should be the same as that. You can see that 100 plus x matches 100 plus x. Once everything's set up properly, again, all we do is create an equation from that by doing percent times amount plus percent times amount equals percent times amount. Again, plus this time because there's a plus sign because we're adding. So 20 times 100 is 2,000. We're adding 40 times x. Bless you. We're going to get 35, bless you. We're going to get 35 times 100 plus x. So 35 times 100 is 3,500. And 35 times x is 35x. Distributive property, be careful that we don't forget to multiply both those objects times the 35. For me, moving x to the left, numbers to the right seems to make sense for this one, so move the 35 left, move the 2,000 right. Both things moving, change signs to their negatives in this case. 40 minus 35 is equal to 5, and 3,500 minus 2,000 is equal to 1,500. And if 5x equals 1,500, we divide by 5, we get x equals 300. And then the unit, as Maddie said, kilograms. And we're figuring out kilograms of 40% glycol. Use the boxes, the graphic organizer up here, to establish what x represents, to establish what you need to write down here. How much should they add? 300 kilograms of 40% is what they should add. They didn't ask me how much we'd end up with. If they did ask that, it would be 400 kilograms, right? 300, 100 plus 300 makes 400. So we end up with 400 kilograms of 35%. All they're asking me for is how much we should add.